Hey everybody, welcome to EEs Talk Tech. My name is Mike Hoffman.
And I'm Daniel Bogdanoff, and we're here with Matthew Woerner. Again, he's a metrologist with Keysight Technologies, and I want to make the same joke every episode. How's the weather?
It's still cold.
Still cold. Okay.
like through April.
Being a meteorologist in Colorado is a pretty tough job. I mean,
Almost as hard as being a metrologist in Colorado.
Well, actually, the consumer expectation of you is really low, so actually it's not too bad.
Ooh, that was actually a brilliant segue because today we are talking about consumer and producer risk. So how do you know that when you get something, it actually works or it's not going to blow up in my pocket or while I'm sleeping? So you want to give us a little bit of an overview on that topic as a whole?
Yeah, so it's just talking basically about producer and consumer risk. So consumer risk would be the risk that a company or manufacturer has shipped you or sold you a faulty product, and producer risk is
which is bad.
Yeah, which is bad. And producer risk is the risk that a manufacturer or company has a good product and then chooses not to sell it to you because they're worried it's bad.
Interesting. And I think for me, how this has been relevant is when I had a phone that ran off of a micro USB cable, I would order cheap cables all the time off of, eBay or something, and they'd ship from overseas where manufacturing standards might not be as high, and the cable would work for a while, and then at some point it would just stop working. And the cable that came with my phone worked fine for the life of the phone. So it seems to me that in my head, this is where this comes in. How do I make good purchase decisions? How do I know, risk when I buy something?
Yeah, there's always risk, and we can never totally get rid of it. But, I think most people know what to do to minimize their risk. You'll go on Amazon and read reviews and that sort of stuff. One of the hardest things from a tech perspective is if the system integrator is a common person like you or me, it's a lot harder to sort of manage that risk than if the system integrator is a company with engineers who are telling you what to do.
Like a closed system.
That's right.
Interesting.
And so, actually, that's the reason why we see a whole bunch of organizations like the PCIe SIG and the USBIF and it's the 3GPP for wireless standards.
Okay.
Definitely watch our previous podcast with Rick Eads to learn all about PCI Express and their SIG.
I think we talked to Jed about USB and Johnny Hancock about power, so you weren't there for those, but well done.
I'm just here to shamelessly plug the podcast you're already watching and or listening to. Don't mind me.
Good work, Mike. So why don't we just kind of discuss from a consumer standpoint, is there anything that is our responsibility to do, or is it more just say buy from vendors that you trust and hope?
Yeah.
Works,
so
or,
you don't really have a lot of leverage unless you all bandy together. But providing reviews on Amazon, that's pretty good, right?
Yeah.
Because I check that. But other than that, there's typically, as an individual consumer, there's not a ton of leverage that you have in that negotiating table. Okay. The other thing to do is buy brands that are good and high quality, because then you're voting with your money essentially.
Okay, so what's the difference between you have company A who is just trying to churn out the cheapest, fastest product and turn a quick buck, and then you have company B who's maybe in it for more of the long haul and wants to make sure they have kind of this repeat consumer base. How do their actions look different when it comes to design and manufacturing?
Yeah, so let's look at sort of the final test first. So there's a couple ways that we see people do final test. So the first one would be a functional test.
What do you mean when you say final test? What do you mean?
So the final test would be the test that you make before you ship the product. So let's say I'm making a Bluetooth headset for a car. So, by the way, I don't actually buy anything Bluetooth because I don't trust its reliability. But a fun fact about me. But
it's gotten a lot better in the last 10 years.
But what you'll see, a functional test would be like, okay, if I'm buying a headset, what I'm going to do is I'm just going to take it to my car, see if it works in my car. If it works, then it passed and I'll ship it.
Yeah. So you put it in its packaging and send it out the door.
That's right.
Okay.
So the next thing that you have to do is you can do a full what we call compliance testing. So something like, and I'll plug your first podcast with JIT because I know a little bit about USB, but USB will have a standard where you have to measure, 20 to 30 different electrical parameters of the device. And there's probably more beyond the electrical that Keysight doesn't play in terms of mechanical specifications that you have to meet as well. So the next thing you do is you physically test it throughout the whole compliance suite.
And that's something for a little more than like a cable per se. Like for a cable, you'd maybe just check the different leads. But for a phone, you want to make sure that it's actually going to, when I plug it into a computer, it's going to recognize it as a USB device and function that way.
Yep, exactly.
Okay.
Now, a follow-up question. Daniel asked kind of what does the manufacturing side look like between company A and B who's flipping the quick buck and then for the long haul. I have an interesting anecdote that I'd like to share with you two in the audience today.
No,
no, never mind. No,
so, we're out of time for today, and we're picking on Mike today.
It's okay. It's okay. So it was an interesting story. The history of the ballpoint pen. So it's something we kind of take for granted, but the ballpoint pen was invented actually in France sometime in the early 20th century. And there was kind of this race to be the first company to bring the ballpoint pen to the United States. And it was developed down in Argentina, and some people had came down and seen this technology, saw how revolutionary it was, this and that. And this guy set up a company in New York and really hyped up this ballpoint pen. It was the first ballpoint pen for sale in the U.S.
Significantly better than like a quill and ink. Have you ever tried to write with one of those?
No.
My brother got one for Christmas. He was writing this. It was like really impractical.
Well, there's a side note from where I'm going with this conversation, but there's a lot of people who denounce the ballpoint pen because they think that, because when you write with a ballpoint pen, it's an equal width line that you're drawing versus with the quill where you can kind of have a third dimension. Yeah. People are like, oh, calligraphy is going out the door, this and that. But this guy was hyping up this ballpoint pen, first ballpoint pen you can buy. We're talking like Apple, lines outside, people like filling the streets lined up to be the first person to get this ballpoint pen. And they were absolute trash. And what he did, though, is he said lifetime warranty on the pen. And so people were like, okay, great, this futuristic sci-fi product, right, which it seems kind of silly today. And they ended up replacing hundreds of thousands of these pens over the course of the next couple of years because they'd break and then he completely went out of business.
Sure.
10 years later, we have a company, I think everybody has one of these at their desk, BIC, comes through spend a little more time on R&D. You don't really get a warranty on a BIC pen, but they pretty much last forever. So my question after all that is, when you see a product that has a warranty, it kind of gives you some peace of mind as a consumer, and you could see that as kind of a way to hedge your bet on the quality of the product. But if a company's offering a warranty on something, does that speak to their confidence in the reliability or them wanting to essentially draw you in to buy the product?
Well, I'm sure they're trying to get you to buy the product. But really what a warranty does is it transfers the consumer risk to be a producer risk. So the producer of that product is essentially saying, we want you to buy it. And we know our customers don't want to take a lot of risks that the product we're selling doesn't work. So we're going to pay money and set up an infrastructure where we can repair and replace any products that happen to be broken within the warranty.
How do they go about determining, and this is maybe not your question because it's more of a reliability engineer question. How do you go about even deciding you want to offer a warranty? So, off the top of my head, recently we changed from 3 years to 5 years on some of our scopes. So how is that decision made?
Well, here in Keysight, I think it's a marketing decision based on, does that give us a higher probability that someone's going to buy our instrument versus a competitor's?
Yeah, but it's so much more than that because it's not just, if I had it my way and marketing had their way, it'd be like, all right, 30-year warranty on everything, we're good to go.
We've gone down that route and been shut down.
But at some point, there's a cutoff. It's a balance of, okay, well, I can consistently say, 5 years is we're willing to cover all that risk because anything that goes wrong is okay. That was a legitimate error versus just something ages out, which happens, right?
Yeah. So I don't know. So some of the data that Keysight has, so we have failure rates. So we track annualized failure rates for all of our products. And so that'd be one data input that we would use. The other thing that we can do, sort of from a metrology standpoint, is you can build reliability models of your instruments. And the most common reliability model, I think is most common because it's easiest to implement and use, is an exponential model, which essentially says that the probability that your instruments go out of spec or fail is the same in year 1 as year 2. And so
this is true for all electronics, right? It's not just a test and measurement equipment thing, I would imagine.
So I imagine that, other electronics will track data just like we do.
Okay, so carry on. Is it same failure rate
from year
perspective
1
as
to year 2?
year one to year
So
two.
it's the most conservative model that we have. And so you would be able to say, okay, we have this failure rate in year 1 or over a 1 year period. So 5 years, we're going to have X amount. So that means, the warranty is worth this much or should be worth this much to the customer. And it's worth this much to us.
Okay.
Because we know how much we're going to have to repair.
I guess you could weight in warranty costs into price of equipment and everything, or price of whatever you're selling.
Yeah.
So if I know that 1% fails, which is kind of is a reasonable expectation, then, and we have a 5-year warranty, then maybe 5% of the cost is, warranty.
Yeah.
So it's producer risk, basically, that we're.
That's right. That's additional producer risk that you're
taking on.
It's
like a subprime producer risk that we chop up among all the scopes and sell it as.
Well,
that's not really what happens.
feel free to correct my path here if we're getting off track, but
Probably,
this.
Worth
No
it.
respect. No respect.
Not your fault, yeah.
So you're talking about AFR and risk for the consumer and risk for the producer and all this.
AFR being annualized failure rate.
Yeah. So that's something you're able to learn over time of a product being in the market. But how can we? And tell me if you can speak to this. How can we determine or predict what that will be before something is launched in mass?
Yeah. So downstairs in this building, we have a temperature chamber. And so what we do is we put it in the temperature chamber and run the oscilloscope at 40 degrees rather than 23 you might find in the office. So that'd be centigrade. And I don't really speak to this, but that's how we can get an estimate of how it's going to do after 3 years, how it's going to do after 5 years, how it's going to do after 10 years.
Yeah, I actually had a pretty cool conversation with one of our lead test engineers who talked about how statistically stringent components are over time and electrical systems are, and you can actually accelerate the aging and artificially age something with something like a temperature chamber and then extrapolate based on your findings into a pretty good idea of how something's going to do. But then every once in a while, you get something like what happened recently in the news. There was a large electronics phone manufacturer who had some what I would deem pretty significant issues, right? So how do you balance, and how is that balanced with, okay, I think my margins are good, my tolerances for what is acceptable versus this thing catching on fire? Yeah,
so one of the things that's really interesting to me when I was researching about this particular incident was they had a metrology. We'd use a term called false accept.
Mm-hmm.
You could call it an escape or a false pass is what I've also heard it called, of 0.1%. So it's essentially zero.
So false yes means it's okay, or it tests as okay even if it's not.
That's right.
Okay.
So they're shipping, that'd be if you're shipping a bad product to a customer. That's essentially your consumer risk.
And the escape rate meaning it escaped factory being
good. Yeah,
Good.
they all mean exactly the same thing.
Yeah. Okay.
People just call them different things.
Escape
sometimes.
rate sounds a little more dramatic. So
yeah, the escape rate of this phone was 0.1%.
So 1 in 1,000 were not as good.
Bad. Yeah. So if you were to go buy it, odds are it's good, but it's still $1 billion problem for them. So, I mean, it's interesting how much quality has to be put in. And this company actually just came out and said
results.
here's the results of our findings. But they spent so much to have those results, and
Mm-hmm.
I think that was really about them trying to build customer confidence back in their products. Because yeah, we know what's going on.
Yeah, it makes sense.
Yeah.
So how do you go about? Obviously, there are catastrophic product failures that happen. How do you go about avoiding the less catastrophic things?
Yeah, so I can speak to what Keysight does, which sort of can then be extrapolated to what any company can do.
Sure.
But so when we make measurements, what we try to do is we try to estimate the accuracy of that measurement before we make it.
Okay.
And so I say accuracy, but if you like go deep into metrology definitions, the sort of the key point is the true value of whatever you're measuring. So let's say we have a coffee cup here and I wanted to measure how much fluid can I fit inside of it. Well, I can never actually precisely know exactly what that is, but I can estimate it by measuring, so I can measure with like maybe I have a quarter cup and I fill it in. But then you can estimate how accurate you are, or the bounds of your error. So that's sort of like the difference between the true value and what you've measured.
Okay.
There's an international standard for that called the IS. It's probably not ISO. It's called the GUM, for the Guide for Uncertainty of Measurements.
Okay.
And so essentially, you go and say, let's look at all the errors that we have for this measurement. So here, if we're using a quarter cup, we say, well, the quarter cup is only precise to a quarter of a cup, and then there's some error from the operator having a non-stable hand and anything else.
And who decided, that quarter cup was close enough to a quarter cup to be counted as a quarter cup?
And is that quarter cup even a quarter of a cup? That's one of the reasons why we calibrate, and your quarter cup may not be exactly a quarter cup.
And this kind of comes back to our SI unit discussion from last time is, at some point it has to be traced back to a specific measurable standard. So volume is harder, I guess. But
so that's the principle of traceability, which is so the test that we might be using here, there's actually a series of tests for us to be able to make this, each with a sort of a more accurate standard, up until we get to the point where we're measuring against the SI standard of length.
Okay. Yeah, that makes sense. So if I have, my phone and I'm running a board off of it, I say, okay, that's 5 volts, and I just let that be 5 volts. But somewhere, someone designed a system that puts out 5 volts, or at least as close to 5 volts as they think they want to get, and then.
So your phone has within the USB hub, it has a 5 volt power supply, and so you could hook up if you were to measure it, you would hook up a DMM to it and to be like, is this 5 volts or not? And depending on the digital multimeter that you use, you could be like 1 part per million accurate, which is with like a Keysight 3458A, or you could be much less than that if you use like a handheld voltmeter that you get anywhere.
Okay.
But one of the key things is, over time, we know that electrical components age and wear, and lots of sort of little things happen to them that can change the performance of it. And that's why we offer calibration services, is so that that the voltmeter that you're using is still accurate.
So it's kind of a bit of a scary thing for anyone using any sort of measurement tool, right? Like even if I go to weigh myself on a bathroom scale versus a, calibrated weight off, I don't know what they
shipping
call
scale
those.
or something.
Yeah, at the doctor's office, or someone who's making, like a shipper who's making money off of the weight, and it has to be very precise. Depending on what you're doing, you want to make sure you're actually being pretty cautious with the source of your measurements, right?
Yeah, absolutely. And actually, it turns out it's best to buy gasoline at 4 a.m. in the morning when it's coldest, because then you get the most weight per volume.
Oh, good to know. I should have gotten up earlier this morning.
Yeah. It only saves you a cent maybe, but
over the course of a lifetime, that's like $5.
Yeah, that's right.
It's real money.
Yeah. Gone like that. Interesting. Okay, so is there anything that people in general should do? So, what now? Like, okay, you just be cautious. You build margin into your design.
Yeah. So so there's lots of ways that you can attack this, right? But we do know that when we're talking to our customers now, so designers, one of the biggest problems that they're seeing is that as we go to faster and faster data rates. So Rick came and talked about PCI Gen 4. Well, that's super fast. And all of a sudden your margin is really, really small. And so we see that margins and a term called margin stackup start to be really, really big engineering problems.
Okay. So when we talk about margin, it's like, okay, it has to be 5 volts, but I'm okay with 4.5 to 5.5 volts.
Yeah.
So that my margin is a volt there. So what is margin stackup? I could probably infer from the name, but
yeah, so you can think that within an electrical system, there's a whole bunch of different components. So you have your chip, and then you have your chip layout, and you have your a board, and then your board gets put into a final product. And all of these different things have error associated with it. And so when you design your chip, you want to make your chip. So let's say you're designing a chip for, PCI Express. So that's going 16 gigabits per second. It probably has a jitter spec in like the...
I think it was femtoseconds.
Yeah, femtoseconds probably.
Tiny,
it's
yeah.
really, really small. So all of a sudden, if you design that chip, you have to think, well, the end product has to have jitter in the femtoseconds. So that means I need to have it less than that so that we can correlate for that. But the other thing that you want to, or plan for that, but the other thing that can help is if you have a full test strategy going from the chip level to the board level to the final product level, what you end up seeing is less variance between these different testing that you have to do. And then you get less producer risk and less consumer risk.
okay. Now, go ahead. I thought you were about to say that. There's a whole industry built around metrology, and that was not something I was even remotely aware of when I started working at Keysight. But there are companies, including us, who will calibrate equipment, and I'm sure this is true for medical equipment, for any sort of equipment out there that involves making sure quantities read by machine are correct.
Go get your car, alignment done, right?
Yeah,
It's all over the place,
my
right?
elevator. I want my elevator to stop at the right floor, and the brakes to have appropriate margin.
But more importantly,
situation.
not only do you want your elevator to stop at the right floor, but you don't want it to have this little step there that no one's planning to have, so that they don't all trip and fall.
Mind the gap, yeah.
So there's a whole industry built around making sure things work the way they're supposed to. What does that look like as a whole? That's kind of a broad question. So, yeah.
What does it look like as a whole? Thanks, Daniel.
So it's not something. Yeah, anytime. You just I get into an elevator and I look at the certificate because you're standing there looking straight ahead with your arms at your sides like you're supposed to do.
Not talking to anybody or making eye contact.
Right. And
awkwardly,
not breathing too loudly or anything. And there's a certificate on the wall that says, okay, it's been inspected and we knows that it's going to work. And that comforts me. Is there anything that will help comfort engineers or people buying products from engineers? So I want my phone to work, right?
Yeah. Well, so for a lot of things, there are certificates, right? So USB-IF has certificates, PCI Express. So PCI SIG offers, I don't know if they give certificates, but in order to use PCIe, it's sort of trademarked.
Certification,
You
right?
have to be certified. So there's that.
Okay. So, getting things that have the label on them instead of it says
Yeah.
USB compatible, even one with the USB
Yeah,
sticker.
your cheapo eBay cables were probably not USB certified. Right?
Yeah, my guess would be no.
Yeah,
They worked for a while, though.
that's right. But then you had to buy them again.
I did. Yeah, so I probably went through 5 of them when I could have just bought it.
One for
From
4
a
times as much.
Yeah.
Yeah, it'll last about the same. I don't know. Hard to say. Yeah, any other questions for Matthew on this, Mike?
What do you think is your biggest challenge that you deal with here at Keysight every day, making sure that our products do have the highest quality?
Well, what do I do to make sure our products have the highest
Or,
quality?
I think being more familiar maybe than Mike with your job is how do you make sure other people have confidence in what they're doing?
Yeah. Okay. So let's say you're doing tests, and I know it's not supposed to be a test blog, but if you're doing tests, so one of the things that happens, there's a lot of things that you can do to help ensure that you're making high quality measurements. And what we do know is making high quality measurements reduces your consumer and producer risk. So all the risks that you have. So one of those is calibration. And so if you want to go have an instrument calibrated, there's a couple things that you have to look at. There's really 3 stages that happen. And this is actually what happens for calibration is the same thing that should happen on the manufacturing floor, because
For anything, I mean, everything gets calibrated, right?
yeah, right. So I mean, technically, before you ship your phone out, they make measurements. Calibration is just measuring by definition. So the first thing you have to ask is what you care about being measured. So let's give an example of something complex. So you guys are oscilloscope guys.
Yep.
So let's say you want to go make a jitter measurement. We referenced that previously. Well, Keysight and Tektronix and LaCroix will all publish their jitter floor. So if you care about your jitter floor, what you really want is to have either your jitter floor measured or all the components of that make the jitter floor measured. So for an oscilloscope, that's going to be your time base, that's going to be your bandwidth, and that's going to be your noise floor. Did I say noise floor?
No. That's the
Okay,
one,
great.
yeah.
Trying to put words.
Vertical
on.
noise, timing noise. Yep.
Yep. So that's what you had to consider, and so that's the first question is did that get calibrated? The second question you have to ask is did it get calibrated accurately? And the third question that you have to ask is if it was out of spec, what did that provider do?
Okay.
And by the way, if you care about your phone and it's getting shipped, now I don't care about Bluetooth because I don't use it, but maybe you guys do. So if you're buying a phone, what you really are hoping is that the Bluetooth gets checked if you used it, but maybe I don't care about it because I'm not going to use it anyways.
When's the last time you bought something with Bluetooth? What's this fear stem from?
Are you still on a flip phone? You were on a flip phone for a while.
I was. It came from actually like Bluetooth mouse probably like 6 years ago.
I remember the first Bluetooth device I bought in 2006, freshman year at college. I was excited. My phone wasn't Bluetooth compatible, but I bought Bluetooth headsets and then a Bluetooth to like audio jack
nice.
adapter,
Oh, yeah, I had
so I
one
could
of
keep my
those
phone,
too.
everything in my backpack, and it was such a piece of work.
Yeah.
Yeah, and it kind of disillusioned me from Bluetooth for quite some time. You'd buy the speakers, they'd break, wouldn't sync, but it's pretty good now. I'll give it a try, dude.
Yeah,
I think
okay.
you might like it.
Okay.
The problem I have is when I pull out of the garage in our main driver car and my wife is upstairs in the house, it connects to her phone and starts playing music as I drive away, and it kind of drives me crazy. But that's probably not a Bluetooth issue.
That's just
more
her way
of
of saying goodbye to you. Does she ever like play something specifically
She
when you're
should.
pulling out?
That'd be good.
We'll let her know.
Honey, I know you're not watching this, but you should do that. Okay.
All your cardboard cutouts are probably watching, though. More on that later.
Yeah, okay. Yeah, we're actually out of time. So, Matthew, again, thank you for being on the show. We do predictions at this point. So, do you have any predictions based on?
Yeah, I'll give a prediction. I think based on consumer buying habits today, at least in the U.S., product quality is going to go down. Just because I think people tend to buy things based on cost more and more, especially as the complexity of what's being sold goes up.
Interesting.
I think that probably ties into a lot of kind of the replace instead of repair mentality that we're in nowadays because of that complexity, right?
We've actually seen interesting results from certain companies who are doing some manufacturing where they will test differently, their product differently based on the region that product is being sold into. So I won't go into any more specifics than that, but some regions of the globe have a higher tolerance for a higher failure rate than others. It's interesting to hear that.
Yeah, good prediction. I predict that you are going to have to purchase a Bluetooth device in the next 24 months. And
24 months.
There'll be no option.
If it's been 6 years since you bought a phone, you're probably due.
I bought a phone pretty recently.
2010. Yeah. Oh.
Yeah, but I've actually been thinking, because I work from home sometimes, I would really like a headset to have phone calls on because I like walking and talking.
I'm going to buy you a Bluetooth headset as a thank you for coming on the podcast.
Well, that'd be very generous of you.
But that would
Michael.
ruin your prediction because your prediction was that he was going to buy one.
My prediction is I will force my prediction to become true by buying him a Bluetooth headset.
He's going to sell it to me at under market value.
Yeah. 1 penny. So my prediction is a little more silly. I think we're going to start seeing buyer and consumer risks on apps like Tinder. So,
Oh,
Please continue.
no,
Nope,
I could
I'm
see
done
that.
there.
I've seen people talk about how that people or that everything that you do, like we're all going like this futuristic side where we're all individual contractors, and based on every work that we do, both we get reviewed as like whatever work we're doing, as well as the company, and then people will start making decisions based on how they're getting rated.
kind of like the Black Mirror thing.
I was about to say.
Yeah. Yeah. Well, we're out of time. I don't want to dive into that. Thanks for tuning in. If you're interested in learning more about calibration on any equipment you have, where should you go, Matthew? Website?
You can, yeah. So we have a www.keysight.com/find/Americas_Cal.
CAL.
Yeah.
Okay. Awesome. We'll put a link in the description of this. So we had Matthew Woerner. Thank you for being on the show. Mike Hoffman, or colloquially known around the office as Hoftron 9000.
That's the name of my phone when I connect it to my Bluetooth stereo.
Mine is Snoop Bog.
Snoop.
Because my last name is Bogdanoff, so a lot of people call me Bog. So it's Snoop
fresh.
Bog. Yeah, it's
fresh.
something else. I didn't come up with it.
He also has a
Just for the
fledgling
record.
rapping career.
That's not true at all. So thanks for watching. Make sure you subscribe to the Keysight Oscilloscopes YouTube channel, and we will see you the second and fourth Thursdays of every month.
Comes on the mornings. See him, follow, see the